Hey guys, this is Mr. Mood. Today we're going to talk about domain and range again. And this is actually the second part of the lesson over domain and range. At the end of this lesson, you're going to be able to find the domain and the range of a function from a graph. So the best way to do this is to just do an example. So we're going to find the domain and the range for the following function. As you can see below, we have a curve, shown in blue with the red endpoints. And I've made the endpoints kind of big and red so you guys see them this first time through the process. We're going to use these endpoints in this curve to draw a box that our shape, our curve, is going to fit inside of. And we want it to be the smallest box possible. So we're going to have to figure out how far to the right and the left does this curve go, how far up and down does this curve go, and that's going to be the edges of our box. And the box should look something like this. So now we're going to move that off to the side, and we're going to talk about domain. The domain is determined by the width of this box. So the left-hand side of this box is at -2, and the right-hand side of the box is at +3. So we're going to use that to set up our inequality. So you know that the left-hand side is going to be on the left of this inequality, the right-hand side is going to be at the right, and then x is in the middle because we're talking about domain. So in our case, the numbers should go as this: -2, x in the middle, and then 3 on the right. And the general rule of thumb is that the inequality always goes from our smallest number to our biggest on the right. So we've got an inequality in between the x and the -2, and we always read the inequality from the x. So this tells us that x is a number greater than or equal to -2. So the -2 corresponds to the shaded in circle. The reason that it's equal to is because it is shaded in. The rule of thumb is anytime you fall on a shaded circle or on the curve itself, you're going to have equal to. Now it's greater than because if you look, every number inside of our box has a larger x value than that. Therefore, x is any number greater than or equal to -2. On the other side, we've got the 3, which corresponds to the open circle. And because it's open, that tells us that it's not equal to. Now, the reason that it tells us that x is less than 3 is because if you look, every number inside of that box has an x value smaller than 3. Therefore, x can be any number less than 3. So rewriting our domain, we have -2 is less than or equal to x, which is less than 3. And then we're also going to write this in something called set notation. So we've got bracket -2, comma 3, parentheses. And the reason we have the bracket is because that side has an equal to, and the other side doesn't have a bracket, it has a parentheses because that side is not equal to. So equal to gets a bracket, not equal to gets a parentheses. Now we're going to find the range of our function, and the range is determined by the height. And the top is at +2, the bottom is at -5. So we're going to go from smallest to biggest. That means that our bottom's on the left and our top is on the right. For us, that means we've got -5 followed by y followed by 2. And again, the inequality goes from smallest on the left to biggest on the right. Now our -5 corresponds to the open circle, which tells us, just like last time, that it's not equal to. And it tells us that y is greater than -5 because if you look, every number inside of our box is bigger than -5 for the y. It goes up from there. And on the other side, we've got the shaded in circle for the 2, which tells us that our inequality is going to be equal to. And the reason that it tells us that y is less than or equal to is because every number gets smaller from that 2, it goes down. So in this case, we have y is less than or equal to 2. So our inequality for the range looks like this: -5 less than y less than equal to 2. And in set notation, we're going to have -5, comma 2, where the parentheses is next to the 5 and the bracket is next to the 2. Now let's find the domain and the range of the following function. Now this one's a little bit different because this one has an arrow at the end of this line, and that tells us that that line goes in that particular direction forever. So we're going to figure out where the sides and the top and the bottom of this box are. Let's start with the domain. So the left-hand side of this box is at negative 3. The right-hand side of this box is at infinity because, as you can tell, this line goes to the right forever, shown by the arrow. So our domain looks like this. We have negative 3, x, and then infinity. Now the negative 3 is equal to because it falls on the shaded dot. Now the reason that x is greater than negative 3 is because every number gets larger than that from there. And for the infinity, we have x is less than infinity. Now the reason that this one isn't equal to is because we can't ever reach infinity, so whenever we have an infinity involved, we're never going to have an equal to. Or if we write this in set notation, we're going to have negative 3 comma infinity with a bracket on the left and a parentheses on the right. So now let's find the range. The bottom of this is at negative 1, and the top is at infinity, and we know that because the arrow tells us this line goes up forever. Now the inequality looks like this. Negative 1, y in the middle, and then infinity on the right. So we have y is greater than or equal to negative 1. And the reason why it's equal to is because it falls on the line itself. It is the bottom line of this box. And then everything gets larger from that negative 1, so that's why y is greater than. Now as for the infinity, just like before, anytime we have infinity, we can't actually reach that, therefore we're never going to have an equal to. And then every number is smaller than that, so y is less than infinity. If we write this in set notation, we have negative 1 comma infinity, where the bracket is next to the negative 1, and the infinity has a parentheses next to it. So to wrap this up, we find the domain and the range by fitting our curve inside of a box. And then any side that has an arrow is going to have no side, which means it's going to go to infinity. For the domain, we find the sides of the box. For the range, we find the top and the bottom. We use not equal to or a parentheses for an open circle. We use the equal to or the bracket for a closed circle, or any spot that is located on the curve itself.
That's all, folks.